Hello, guys, and welcome to this new series on Benford's law. So, I don't know why I keep saying architecture. Um, yeah, it's a very interesting sort of more statistical of maths that I came across when reading, and I'm excited to share a lot about it with you guys in this series. So let's go. First, let's take a look at who the guy was. Frank Albert Benford Jr. born in July 10th, 1883, in Johnstown, Pennsylvania. Um, Yada yada yada. 6 years old. He survived Johnstown flood disaster. Yeah, it's grown up in an industrial landscape. Developed a personality characterized by extreme meticulousness. So I guess you could say he was a inventive guy who's interested in like the intricacies of industrial revolution, the rapid industrial development at the time. Um, he viewed numerical data as being abstract concepts as physical artifacts. Um, that's quite important, and we'll get into that later. So he spent primary professional career at General Electric, research laboratory in New York. I spent 20 years there, and he was a research physicist. This just goes to show that, even if you go and do a degree in physics or whatever, you can still delve into maths because the maths really underpins most, if not all, of physics and engineering. Um, During his time at General Electric, authored 109 scientific papers. That's a lot of papers and 20 patents as well. So he was, yeah, he was a really good guy, I guess. He was a pioneer in photometry, but his most enduring contribution was a statistical law, which we're going to talk about today. Okay, so let's actually get into the meat and potatoes. Mystery of the one pages. So the phenomenon was first noted by astronomer Simon Newcomb. He observed that initial pages of logarithm tables, those containing numbers starting with 1, were more worn than the later pages. So he published a brief paper in Journal of Mathematics, blah blah blah. So this is basically saying that he found that within a logarithm book, so this is what they used to use to find the logarithms of different numbers and stuff back in the day. They used to have a massive book, and then they'll turn to the right page. So say you wanted to find log base 10 of 673 or whatever, then you go to log base 10 section and 673, and then, yeah, basically. So he found that numbers that started with 1 were the ones that were most worn. So that's interesting, and we'll get on to an explanation of why soon. This guy still discovered it, but he didn't really develop an idea as to why that was or anything. Yeah, quite interesting, quite strange, maybe. In 1938, Frank Benford independently noticed the same way on his books at General Electric. Unlike Newcomb, he had the industrial resources and the determination to prove the theory through brute force testing. So he spent years collecting and analyzing 20,229 distinct data sets. He looked at diverse numbers, such as the area of like 335 rivers across continents, physical constants from textbooks, numbers found in random magazine articles, and death rates in different cities. It's a bit morbid, but yeah. He found that in every single set of naturally generated data, the distribution of leading digits followed an identical, predictable curve. So you might be watching this video and thinking, like, how is that at all significant or interesting? But just think about how weird it is that in such vastly different data sets, there was a common a theme, a pattern, if you will, on what how often a certain starting digit would occur in the data set, which is kind of crazy. And the fact that it's consistent across, you know, over 20,000 data sets is absolutely ridiculous. And it's quite interesting. Um, yeah, I don't know, I like it. So that's all for this first video. And we're going to episode three, the mechanics, how it all works and why it follows such a predictable curve and why this actually occurs. It's quite interesting. So I hope to see you in the next video.